Okay, so I just want to continue from the previous problem. I just want to say a few last thoughts. I got to 10 minutes and wasn't able to finish a couple of thoughts, so we're just going to extend this into the next video. So this is from video 3.0. We did this and we're going to extend this in video 3P. Okay, so we found that if you launch it at 15 meters per second at 35 degrees, you get an initial vertical velocity of 8.6 meters per second, an initial horizontal velocity of 12.3 meters per second, and it's going to travel, and if it drops negative 50 meters, it's going to travel a time of 4.2 seconds. Now we can figure out this, and we can figure out these two things here, and we can maybe talk about that negative down there. Okay, so this one's pretty easy. Because my horizontal acceleration is 0, so that goes away. So I have x horizontal that's going to be 12.3 meters times 4.2 seconds. That's going to be 52 meters. So it travels a horizontal distance of 52 meters. And let's figure out that right there. Okay, the easiest way we're going to do this one, let's flip to a different equation. Let's say A is equal to VF minus VI over T. And so we're going to get VF equals VI plus AT. So we're going to get 8.6 meters per second minus 9.81 meters per second squared times 4.2 seconds. And squeezing that in all the way down at the bottom of my page, we're going to have 8.6 minus 9.81 times 4.2 is going to be negative 32.6. Okay, now very quickly, that means that when it comes down, it's still going the same way at 12.3 meters per second. But now it's coming down at 32.6, and so I can use Pythagorean theorem to solve that. And it's going 34.8 meters per second, and angle shift tangent 32.6 divided by 12.3 is 69 degrees. So it was launched at 35 degrees and is coming down now at 69 degrees. Now the last thing that I want to talk about here in just a couple minutes is this negative time and this positive time. Well, here's my cliff, and the ball kind of comes and does that. This is what the ball does. Now this time here, this time is going to be 4.2 seconds. But this is a part of a parabola. So we can extend this back sort of imaginary in time, and we can extend this back like this. And so this is what the ball actually did, 4.2 seconds this way. But when we calculated the negative 2.4 seconds here, that's this part that didn't happen over here. That's the completion of the parabola, sort of, that never happened. Imagine if you were sitting on a level field and you threw it from this point, and then you measured how long it took to get to this point. It would take 2.4 seconds to get to this point, and then would take another 4.2 seconds to get to that point. Okay, that's all I'm going to say for this video.